Hey, Prop Stat students, Mr. Mitchell here. Today we're going to take a look at creating scatter plots and talk about line of best fit, which will transition into the least squares regression line. So we can take a look at how to do that on the calculator today as well. We'll take a look at that in future videos, future lessons. So let's go ahead and get started here. So we have a list of data and we're comparing, we're doing a botany experiment. So we're trying to see whether root depth of a watermelon plant will determine whether you can increase or decrease the mean weight of a watermelon, okay, to the nearest pound. So basically what we're trying to see is if the plant can grow its roots further down, does that make bigger watermelons? Because if that's the case, then we want to try to encourage root depth and make sure that maybe we loosen up the soil more, provide it with better nutrients so that it can get deeper root depth. Maybe the plow needs to dig deeper for when you're planting. Maybe the time of the year needs to change a little bit. Maybe it needs to be after a rain. All those things are like variables that we need to be aware of to try to maximize. We don't want to make really small watermelons. We want to make big watermelons because people pay more money for those. Get more money for bigger watermelons. Kind of makes sense. So we want to maximize our weight of our watermelons to maximize our profit if you're a farmer. So it's kind of the idea of what we're looking at. So they measured root depth and then they took all the, so this isn't just one watermelon. This is the mean weight of all the watermelons that that plant produced. So that's what this means, mean weight of watermelon to the nearest pound. So it's not, so it's possible that only one watermelon came from the plant. But if, let's just say there were 5 watermelons that came from the plant, they would take those 5 and find the mean weight of those. So if a plant makes one really big watermelon and then one really small melon, they're going to kind of balance themselves out. Okay. So we can definitely make this by hand. All right. And that's something that you can do. But with technology, we're kind of going away from that. As we get older, this might be more of a middle school thing. And you have done this in middle school where you plot your X and Y points and then you find your line of best fit. So that's what this would look like. All right. You put your points on, you make your X axis, you make your Y axis, and then you draw the line of best fit. You kind of eyeball it. Okay. You have a title and everything. And so what we're going to look at today is not just doing this, because again, that's kind of a review. You've already done that before. We're going to take a look at how to do that with technology. You can do it in Excel. So that's something that I recommend that you learn how to do, especially if you're going to be taking more classes. And we can take a look at that individually if need be. But today we're going to take a look at doing it with our calculator. So we're going to take this list of data. We have an X list and a Y list. So we pull up our calculator, and anytime you need to type in data, you go to stat. We've done this before, but never with 2 variables. We're going to go to edit, and then we're going to type in our X list into one of the lists and our Y list into one of the lists. Now we got to make sure the points match up. You can't just type them in any order you want to. So 26 was the one plant and 20 was the mean weight. So these have to match up. Okay, so you could actually mix those up, but you can't mix up the X's and the Y's. They have to be, 26 has to stay with 20, 14 with 10, 18 with 13, and you see I have done that. Okay, so be careful about that. Be careful that when you type it in that you don't, like if you mean to type in 21, that you type in 21, not 2 or 1 or 211 or something like that. So make sure that you do type in the numbers correctly. It's amazing how many times students will get incorrect answers based on that. All right, that is called human error, and we just have to be careful. Okay, so once you have all your numbers typed in, all right, and you want to make a scatter plot, I want to see if there's a trend so that I can continue. That's kind of the first step in this process. We're going to go to second, stat plot. All right, and you go into one of them. Doesn't matter which one, and you're going to turn it on, and then you're going to select the first thing. That's a scatter plot. All right, you can see this is a histogram and these are box and whisker plots. We're not going to use those right now. So my X list should be my root depth, which was in L1. So that's good. My Y list is L2. That was my mean watermelon weight. So I need to change that. So I hit second L2. Second 2, second L2. The blue are right here. Mark doesn't matter. It's just going to show you the way the point. So if you just rather have a dot, you can put it a dot. You can put it as a plus sign. Color doesn't matter either. The window, this is your standard window. We might not see anything to start with, but then we can work on that. So here's I got some other things in here that we don't need right now. So you can see I can see one point and barely see another. That's because they're not in the viewing window. So what I can do, I can change my window manually. I can bump it. I would change my X max and my Y max, or I can go to zoom. Neither want to go zoom stat or zoom fit. So I'm going to try zoom stat first. Typically when we're doing statistics, you want to choose zoom stat. Sometimes it doesn't work, so you choose zoom fit. So now you can see all my points in a nice window on my calculator. And so you can see the scatter plot. So if I were recording this, if we were doing an electronic presentation or electronic submission, you could screenshot this, okay? If you just had to draw it as a rough sketch, you could draw it as a rough sketch and do it that way. So either way, you have the scatter plot in front of you, all right? And we could estimate the line of best fit. It looks like it's probably be right about in here, okay? So that's kind of the process of making a scatter plot with a calculator. So now if I see a trend, so a trend would be a positive relationship or a negative relationship. If the points are just kind of all over the place, then there's no relationship, we probably stop at this point. So once we have the scatter plot and we think there's a positive or a negative trend, in this case, this is a positive trend, then we would go try to find our line. So we will go to stat. We would go to calc and we would go to number 8, lin reg, and then we tell it our X list. Oops. Tell it our X list, and then we tell it our Y list, and then we calculate it. And so it's going to give us our y-intercept and our slope and our r-squared and our r. And that tells us how good the line is. If you look at r, that's a pretty good line. Gives us our slope, gives us our y-intercept. And the next piece, we would put that in the calculator. So 2.08 plus 0.58x. And I graph it, and there's my line. That's kind of the beginning stages of what we're going to do moving forward. Just going back to take a look at some of the other things. These are an example of, if I get a scatter plot that looks like this, I'm done in terms of doing line of best fit. This has some other correlation, looks like a parabola, okay? So we wouldn't do a line for that. And then these points are all over the place. So if you make a scatter plot and you see these things, you would basically stop. You wouldn't continue, all right? And so if you saw something like this, then you would proceed with your least squares regression equation and continue. So, all right, there'll be more to follow with least squares regression. This is just the beginning. So let me know if you have any questions.